Now, in the previous class, we discussed about in class 7, current electricity, we discussed about the color code and voltage current graphs at different temperatures. Now, let us see the combination of resistances. The combination of resistances. Combination of resistances. There are two types of combination. One is either series combination or it is a parallel combination. First one is series combination. Series combination. Series combination. Now let us consider three resistors are connected in series to a potential V volts. Resistances are R1, R2, R3. Let the current I flows. And the current I is flowing. Now remember, here most important thing is in the current flows, the same current I flows through all the three resistors because there is no junction for the current to divide. If current is like this, junction, if it is junction here, then divides into I1 and I2. But as here there is no junction at all. Therefore, the same current flows through all the three resistors. Therefore, in series, current remains constant. Current I is equals to constant. In series combination, current I remains constant. Therefore, I remains constant. Now, the potential is divided into three parts across the three resistors. Now, the drop across this one is potential is V1. Let the potential is V2. Let the potential is V3. V1, V2, V3 are the potentials across resistors R1, R2 and R3. Now, what is V1? As V is equals to IR, we know that. And what is V1? V1 is equals to voltage across the first resistor. V1 is equals to I1 R1 basically. But same current is I know. Therefore, IR1. Similarly, V2 is equals to IR2. V3 is equals to IR3. V3 is equals to voltage across third resistance is I into R3, I into R2, I into R1. Now, this potential, if you given 10 volts here, this is split into across three resistors. This voltage 10, 2 volts, 3 volts, 5 volts, 2 plus 3 plus 5, 10 volts. If you are given applying 10 volts, the 10 volts is split among the three resistors. Okay. Therefore, now what is V? Effective on 10 volts is equals to 2 volts, 3 volts and 5 volts. Therefore, V is equals to V1 plus V2 plus V3. Now what is V here? V is equals to I into R. What is R? R effective. Let R in series. We take it as they are in series now. The effective resistance, total resistance. What is V here? Total resistance into total current. Total resistance is combination of three resistors. Combination of three resistors. Let's call it RS series combination. What is the combination here? Series combination. So I into RS is equals to I into RS is equals to I into R1 plus I into R2 plus I into R3. This implies IRS is equals to I into R1 plus R2 plus R3. I gets cancelled. Implies RS is equals to R1 plus R2 plus R3. This is the effective resistance when they are connected in series. RS is equals to R1 plus R2 plus R3. If you are connected n resistors, then this continues R1 plus R2 plus R3 plus R4 plus so on and so forth. It continues up to n number of resistors. Now, a small note here. Now, the current remains here. What the current remains constant. V is equals to IR. I is equals to constant. This implies V proportional to R. Therefore, V1 is 2, V2 is 2, V3 is equals to R1 is 2, R2 is 2, R3. R1 is 2, R2 is 2, R3 in case of series combination. Similarly, if there are n resistors of same value, n resistors of same value are connected in series. Then effective resistance is Rs is equals to R plus, so on so forth plus R n times, so on and so forth to n times. Therefore, and what RS? RS is equals to n into R. RS is equals to n into R. That is the series. Something about the series combination. Now, in this series combination only, the very important one that is used in the problematic part is the voltage division formula. The voltage division formula. So, what is that voltage division formula? Is voltage division formula. Let us say in circuit may given so two resistors connected to a supply V volts. This is R1, this is R2, this is current I, this is V1, this is V2. Immediately you ask it to calculate, in the problem you are supposed to calculate what is the voltage across R2, what is the voltage across R1. The further you could need not do all this simplification. Now for this one, what we have, what is V1? V1 is equals to I R1. What is V2? V2 is equals to I R2. What is V? V is equals to V1 plus V2. And what is RS? RS is equals to R1 plus R2. RS is equals to R1 plus R2. Here in all, the current remains constant. In series, what we assumed? Current, not assumption. It is a perfect value. That is, the current is equals to constant. Therefore, I is equals to constant. Therefore, I total I is equals to V by R. V by R, voltage effective by total voltage by total resistance. Total volt is equals to the current across resistance I is equals to V1 by R1. This also equals to V2 by R2, isn't or not? V is equals to V by RS is equals to V1 by R1. That also equals to V2 by R2. If you take first these two, take this two, then what is V there? V by RS means R1 plus R2. RS is equal to R1 plus R2 is equals to V1 by R1. This implies V1 is equals to R1 by R1 plus R2 into V. V1 is equals to R1 by R1 plus R2 into V. Similarly, what is V2? If you consider these two, how to get the value of V1? R1 by R1 plus R2 into V. How can you get the value of V2 from these two? V by R1 plus R2 is equals to V2 by R2 implies V2 is equals to R2 by R1 plus R2 into V. V2 is equals to R2 by R1 plus R2 into V. So this is what is called as voltage division formula. This is voltage division from V2 is equals to R2 by R1 plus R2 into V. Similarly, V1 is equals to R1 by R1 plus R2 into V. Similarly, what is, if n resistors are there, what is Vn? Vn is equals to Rn by Rs. Total effective resistance Rn by Rs into total voltage Vt. Total voltage here we take as V, that is Vt or simply V, no problem. Vn is equal to Rn by Rs into V. That is the something about the series combination of resistors. Now let us see the parallel combination of resistors now. Parallel combination of resistors. Now, in series combination, now let us see the parallel combination of resistors. Number 2 is parallel combination of resistances. Let us consider again, take 3 resistors. Three resistors connected in parallel to a supply. 3 resistors connected in parallel to a supply. This is current I is flowing. This is resistance R1. This is resistance R2. Resistance R3. Supply is V. Supply is V. Okay. Now here three resistors are there. You see, current is flowing like this. It is splitting into 3 at this point. Same current cannot flow because node point is here. The junction point is there. This is junction. A junction point is there. Therefore, the current splits into 3 parts: I1, I2, I3. Therefore, this current splits into I1, I2. This is I3, I1, I2, and I3 here. Now, this what is the potential now across this resistance? See, this is resistance, this is resistance, this is resistance. So, for these, between these 2 points only, R1 connected, R2 connected, R3 connected. Between those 2 points only, a potential also connected. Therefore, same potential applies to all the 3 resistors. Same potential applies to all the 3 resistors, because here, between the same 2 points, 4 parts are connected here. Resistance R1, resistance R2, resistance R3, and also potential. Therefore, the potential remains constant. Therefore, in parallel, important point, in parallel, potential or voltage remains constant. Therefore, V is equals to constant. In series combination, current remains constant. In parallel combination, voltage remains constant. Okay, because the same voltage is applied between these between this resistance, and between these 2 points. Between these 2 points, same voltage. Between these 2 points, same voltage. Between these 2 points, same voltage is applied. Now the current is split into 3 components. Now I is equals to I1 plus I2 plus I3. I is equals to I1 plus I2 plus, and because the current 10 amperes of current, it divided into 3 parts, 2 amps, 3 amps, 5 amps. Therefore, the current I is equals to I1 plus I2 plus I3. Now, what is I1? I is equals to V is equals to IR. I is equals to V by R. Therefore, same potential means V remains constant. V by R1. I2 is equals to V by R2. I3 is equals to V by R3. I1, I2 and I3. V by R1, V by R2, V by R3. Now, what is I there? I is equals to potential remains constant by effective resistance when connected in parallel. Now, what is the total voltage by total resistance? Total current is equals to I total is equals to V total by R total. Now, what is I total? Nothing but I. What is V total? Nothing but V. Now, what is RP? That we have to calculate now. That is effective resistance in parallel RP. Therefore, I is equals to V by RP. This implies V by RP from this equation. V by RP is equals to V by R1 plus V by R2 plus V by R3. Here V remains constant. Therefore, V by RP is equals to V into 1 by R1 plus 1 by R2 plus 1 by R3. V gets cancelled. Implies 1 by RP is equals to 1 by R1 plus 1 by R2 plus 1 by R3. In parallel, we get the reciprocation. 1 by RP is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So that is the parallel combination of resistances. Now here, as V is equals to IR, implies I proportional to 1 by R. I proportional to 1 by R. Therefore, I1 is 2, I2 is 2, I3 is equals to I1 is 2, I2 is equals to 1 by R1 is 2, 1 by R2 is 2, 1 by R3. 1 by R1 is 2, 1 by R2 is 2, 1 by R3. V remains constant. As V is equals to constant, I proportional to 1 by R. Therefore, I1 is 2, I2 is 2, I3 is equals to 1 by R1 is 2, 1 by R2 is 2, 1 by R3. Now, if N resistances are connected in parallel, then what is the effective of equal values? Then what is the effective resistance? N resistors are connected in parallel. N resistors. Therefore, effective N resistors 1, 2, 3, 4, so on and so forth. N resistors R1, R equal R. And well, then what is effective resistance? 1 by RP is equals to 1 by R plus 1 by R plus 1 by R plus so on and so forth plus 1 by R n times. Therefore, 1 by RP is equals to 1 by R, 2n by R, 3n by R, 4n by R, n by R. This implies Rp is equals to R by N. Rp is equals to R by N. In series we get Rs is equals to N into R. In series, there's no way. You see R is equals to N by R. In parallel we get Rs is equals to Rp is equals to R by N. Therefore the resistance gets increased in series, effective resistance, whereas in parallel the resistance gets decreased. In series the resistance gets increased. Now for example, two resistors are connected in parallel. Let us say two resistors R and R connected in parallel. Then effective resistance is 1 by Rp is equals to 1 by R plus 1 by R. That is equals to 2 by R. Rp is equals to R by 2. If it is 100 ohms, then the effect becomes 100 by 2, 50 ohms. The resistance gets decreased in Rp. And in parallel combination, the resistance gets decreased. Whereas in series combination, if they are in series, then what happens? R plus R. Rs is equals to R plus R. That is equals to 2R. If it is 100 ohms, this becomes 200. If it is 100 ohms, this becomes, if R is equals to 100 ohms, then this becomes 200, this becomes 50. Means resistance gets decreased when connected in parallel and increased when connected in series. So keep it in mind. One more thing is useful in doing the problematic part. See, if a 1000 ohm resistance or a 100 ohm resistance is connected in parallel with a 1 ohm resistance, then what is the effective resistance? You can tell effective resistance is almost equals to 1 only. How? Means if these are connected in parallel, no? Therefore 1 by Rp is equals to 1 by 100 into 1 by 100 plus 1 by 1, that is equal to how much? 100, 101. Therefore Rp is equals to 100 by 101, approximately equals to 1, no? 0.999, approximately equals to 1. Therefore a high resistance in parallel with a low resistance always gives a low resistance only. High resistance in parallel with low resistance always gives a low resistance only. Whereas the current in series, then what happens? 100 ohms, 1 ohm. The effective resistance Rs is equals to 100 plus 1, 101. High resistance approximately equals to 100. High resistance only. In series, high resistance in series with a low resistance. Effective is high resistance. In parallel, high resistance in parallel with low resistance. Effective is low resistance. We can neglect this 1 ohm. We can neglect this 1 ohm. Okay. Now, what is Rs by Rp now? In this case, what is Rs by Rp? In this case, what is Rs by Rp? Rs by Rp is equals to Nr by R by N. That is equals to N square. Rs by Rp is equals to N square. This implies Rs is equals to N square Rp. Rs is equals to N square Rp. Okay. Now, what is the for the series? We have discussed the voltage division formula. Let us see what is the current division formula now. Current division formula. This is also this voltage division formula and current division formula are very important in solving the many problems in current electricity. You have expected more number of questions in the current electricity only because it's a big chapter and very important chapter. If you understood this one, this is very easy in your main examination. Therefore, let us take it as two resistors in parallel. Two resistors in parallel to which a supply was connected. Voltage V was connected here. A current I was flowing. It splits in two parts, I1 and I2. This is R1. This is R2. Okay. Now, in parallel, what remains constant? Voltage remains constant. V is equals to constant. V is equals to constant. Now, what is V? V is equals to I into Rp. Is it or not? Total current into total resistance. Total current is I. Total resistance is Rp. Resistance parallel. 1 by Rp is equals to 1 by R1 plus 1 by R2 implies 1 by Rp is equals to R1 plus R2 by R1 R2 implies Rp is equals to R1 R2 by R1 plus R2. This is effective resistance in parallel for the two resistors. R1 R2 R1 plus R2. This is equals to implies what is equals, therefore total V is equals to V1 and also V2. But VR1 also equals to VR2. What is VR1? V is equals to IR. Therefore I1 R1. That also equals to I2 R2. Voltage, total voltage is equals to voltage across resistance R1, voltage across resistance R2, because in parallel combination voltage remains constant. Therefore, IRP is equals to I1 R1, that is equals to I2 R2. This implies I into what is RP? R1, first take these two. R1 R2 by R1 plus R2 is equals to I1 R1. I1 R1. R1 gets cancelled. Implies I1 is equals to IR2 by R1 plus R2. IR2 by I1 is equals to IR2 by R1 plus R2. IR2 by I1 is equals to IR2 by R1 plus R2. So if you take these two, then what happens? These two, this one and this one. IRP is equals to I2 R2. I into RP is R1 R2 by R1 plus R2 is equals to I2 R2. R2 gets cancelled, implies I2 is equals to IR1 by R1 plus R2. This is the current division formula, the most important formula. And current division formula is most important formula. Now, let us see some applications of this one. Let us see some of the applications. Clear? Applications. If a wire of resistance R is divided into n equal parts, and each is divided in each part is connected in parallel, then the effective resistance is, R is a wire of resistance R. Wire of resistance R is divided into n equal parts. So this is a total wire. This is a wire. The resistance is R. It is divided into n equal parts. This is one part. This is another part, another part, another part. What is the resistance of this one? R by n, R by n, R by n, R by n, R by n. If 10 ohm resistance divided into 5 parts, 5 equal parts, then what is the resistance of each part? 2 plus 2 plus 2 plus 2, 2 and 2. Now if these are currently again in parallel, if wire of resistance R is divided into n equal parts and each part is connected in parallel. Now what is this one? So this is one resistance, this is another resistance, this is R by n, R by n, R by n, are connected again in parallel, R by n. Now what is the effective resistance? So I told you that just now I had n equal resistances are connected in parallel. N equal resistors are connected in parallel. Then effective resistance is R by n. Just now we have seen this one. Just now only we have seen R by n. Therefore R effective is R by n. R is each R is anta. Each R is R by n. R by n. R by n. R by n by n parts by n, that is equals to R by n square. That is equals R effective is equals to R by n square. I think you got this one. So here we have taken a wire. The resistance of full wire is R. It is divided into n equal parts. Therefore each part resistance is R by n, R by n, R by n. Now each R by n is again connected in parallel. Each R by n is again connected in parallel. Then what happens? R by n, R by n, R by n parallel. Now if R resistance is connected in parallel, n equal resistance are connected in parallel, then effective is R by n. Just to have derived this one. Therefore, here R in place of R we get R by n. R by n. How many parts? N parts by n. Therefore, R by n square. This is one of the important applications. Next application is a wire of resistance R. Application 2. application 2. A wire of resistance R is bent in the form of a circle. A wire of resistance R, a wire of resistance R is bent in the form of a circle. Bent in the form of a circle. Then effective resistance between the across the diameter is, this is diameter, no? The effective resistance across the diameter is means, see, it is resistance R is bent in the form of a circle. Now what is the resistance of, so what is this part resistance? This is same length as this length. This is same length as this length. Therefore total resistance is that this becomes R by N. This becomes R by N. From A to B R by N. From lower path A to B R by N. N is equals to 2 here. 2 parts only. Only 2 parts. Therefore R by 2 and R by 2. Now across the diameter is asking. Then what happens? This is A, this is B. So this is resistance R by 2. This is resistance R by 2. This is A, this is B. We are taking circle there. Now let us make circle into a resistance part. R by 2, R by 2. Now two resistors are in parallel. Two equal resistors are in parallel. Then what is effective resistance? R effective is equals to R by N square. Here R is, what is R here? R by 2. R by 2. How many parts are taken? 2 parts by 2. R by 2, R by N. Therefore R by 2 by 2. That becomes R by 4. R by 4. Just now also we have derived R by N square. R by 2 square. Just now we derived now for N part N equations R by 2 square. R by that same as that is equal to R by 4. These two are same. Derived generally. This is pi by formula. R by N square is the formula. R by 2 square. But if you do this like this one R, so across the diameter R by 2, R by 2. It is divided 2 parts. R by 2 resistance of upper part is R by 2, lower part is R by 2. These two are again in parallel. Then what happens? 1 by R is equals to 1 by R by 2 plus 1 by R by 2. That is equals to 2 by R plus 2 by R. 1 by R effective is equals to. Therefore 1 by R effective is equals to 4 by R plus R effective is equals to R by 4. Anyhow you can do many methods. Formula R by N square. General method, and also this is also another general method. And last one, if wire of resistance are bent in the form of a circle, a wire of resistance R so it makes some angle here. The center O, it makes an angle here. So resistance is A and B. Therefore what is R, A, B? A wire of resistance R is bent in the form of a circle. So wire of resistance R is bent in the form of a circle of resistance R. Of resistance R, and the effective resistance between the 2 points, which makes an angle theta at the center. Which makes an angle theta at the center is R theta is equals to R theta into 2 pi minus theta by 4 pi square. RAB is equals to R theta into 2 pi minus theta by 4 pi square. R theta into 2 pi minus theta by 4 pi square. A wire of resistance R is bent in the form of a circle, which makes an angle circle, and the effective resistance between any 2 points, which makes an angle theta at the center, is RAB is equals to R theta into 2 pi minus theta by 4 pi square. Let us say previous example only. So here this is resistance R bent in the form of a diameter. The resistance across diameter is, what is the angle here? This is 180 degrees. Is it or not? 180 degrees angle is equals to pi radians. Therefore what is RAB? RAB is equals to R into pi into 2 pi minus pi by 4 pi square. That is equals to pi gets cancelled. R into pi by 4 pi. Therefore pi gets cancelled. R by 4. What answer we got? In previous case, R by 4. What we got in the formula? R by 4. If it is given in angles theta, then you can use this formula. Okay. Next class we will discuss another topic. Thank you.